Hi, everybody. My name is Gabe, and welcome to my talk on prompt engineering. As many know, AI has taken the industry by storm. It's on everyone's minds, and every single person wants to learn about AI, specifically on how it could benefit them. This is great because we're going to learn how to write better prompts, which in turn will help you become more efficient when using AI. So, a little bit about myself before we get started. I've been a software engineer for about 5 years now, professionally, working both in enterprise and small startup environments. I have a master's in computer science from UIUC. While in school, I did a lot of research and helped co author a paper related to AI. And that last point, I absolutely love AI. Here's a quick little overview of what we're going to talk about today. We're going to go into a little bit about what a prompt is, some of the new terminology around AI and prompts, some of the key parts of a prompt, what types of prompts there are, some use cases, and finally, some best practices. The key objective: we want to be able to effectively learn and understand how to write prompts in order to accelerate your workflows. So, before we begin, what exactly is a prompt? So, a lot of people like to associate a prompt with that little chat box where you ask a question. And here's that Google definition: a prompt is a cue, instruction, or a piece of text used to guide a response, whether it's from a person, an AI model, a computer program. It could take many forms, including questions, statements, commands, examples, and it's used to elicit a certain type of output or action. In more layman's terms, I like to think of a prompt as information that helps inform something on what to do. So now that we know what prompts are, what about prompt engineering? So again, the Google definition, but in more layman's terms, techniques that are used to create, improve, revise, and evaluate different sets of instructions. So let's consider the following example. Let's say my engineering manager prompts me and asks, Gabe, I want you to build the landing page. So what's wrong with this prompt? So first of all, what landing page? I have no idea what he's talking about. For what? What specific? Where do you want me to build this landing page? Again, where is it hosted on the same app or maybe a different SEO optimized landing page? Do we have designs? How important is this? How about resources? So these are all questions that I have when he asked me to build the landing page. You could see that just asking me to do something just kind of without any examples or just prompting me to telling me to do something without any context, I have a lot of questions. Let's consider a better example. Gabe, I want you to build a landing page for insert company. You are the only person allocated to work on this project, but that shouldn't stop you from reaching out to others to ask for help. Landing page should be the first place that users land when they log into the main app. We've allocated the entire quarter for you to complete this work, but we don't anticipate you needing most of that time. I'll provide you designs. Let's say he inserts some screenshots as well as product descriptions. Let's say he inserted some product descriptions on how the landing page should look and function. This project is very important, and occasionally you'll see leaders at the company commenting on your work. Iteratively, I want you to follow up each week to give me status updates and progress reports to make sure that you're on track. So, a little bit of the breakdown, we could see that this prompt is a lot better, right? We've got the what exactly he wants me to build, the who exactly is working on it. The why, red includes a little bit of the why. Context, right? The orange is the context, gives me some context on how I should go about some of these tasks and what I need to know about it. The how, purple is that how part. Although it's not specifically how we want to build it, it does give me some instructions on how we want to give, updates, and my manager will give me feedback on how I'm doing. And the feedback, either positive or negative, is very important. We want to incorporate feedback as much as possible, both iteratively and incrementally, right? Same goes when we're talking to chatbots. One more thing before we move on. Again, you could see that this example is a lot better than Gabe just built a landing page, but there are still some, questions that, and you could still probably improve on this a lot more, right? So we'll see that a little bit later on, but let's go to the next slide. So a little bit about vocabulary. You'll hear the term tokens being thrown around a lot. So tokens are the building blocks of our prompts, right? Each word can be broken down into tokens. So on the right, you can see I have the word um, supercalifragilisticexpialidocious, and you can see that the tokenizer, it's highlighting super cali. It's like every four or so um, characters is a token. Sentiment, you'll see that sentiment is your words that have meaning, right? So feeling that are attached to some of the words. When you say something, those words have meaning. Parameters. So when I say, like we're talking about a model that has 405 billion parameters, we're talking about the weights and the biases within a, think of it as like the number of synapses between neurons in a brain, right? So 405 billion parameters, 405 billion weights or synapses in a human brain, for example. LLM, right? We see this everywhere, stands for large language model, right? So a little bit about these LLMs that we're talking about today. They're either trained, diluted, or quantized from large training sets. These models are good at predicting the next thing you want to hear or be told. These are also known as Gen AI models. Lastly, AI agents, right? So another term that's being thrown around a lot. So we're just talking about LLMs that have access to memory, context, functions, and can perform tasks autonomously. We'll see later how we can prompt AI to use some of these agentic workflows, and we'll see that through our prompting. So sampling, right? We're going to learn a little bit later about hallucinations, specifically how AI can hallucinate. But just know that these are some knobs you can turn when working with AI models. Temperature, right? A zero temp means that it'll always choose the highest probability token next, right? Top K, right? If we think about since AI models are predicting the next token, top K means that it's the top K, uh, you know, list of probability the top K is the list of tokens that might come next, right? So higher, more possibilities, lower means there's less possibilities. Top P, right? So if each next token was associated a score or like a percentage of what its probability will be next, then the top P is limiting tokens whose cumulative probability doesn't exceed that P value. Key components of a prompt. So this is very important. We saw a lot of this earlier. So when we're crafting a prompt, it's important to keep in mind these kind of parts of a prompt. The first, and I would argue the most important, is the instruction. What is the exact task that you want to be performed, right? So an example instruction would be generate an image of a doll. Context, right? Things you need to know in order to do your job. So if I prompt the LLM, calculate my 401k contributions if I make X amount and contribute 15%. So the context is knowing how much you make and your contributions. Output and format, also structure and acceptance criteria. So the output format. For example, you could ask the LLM, I want you to generate this piece of text in a bullet point list, or I want you to write this code using JavaScript, for example, right? We can specify in our prompt how we want the response to look like. Another important one is the tone, right? We can have the LLM take on sort of like a persona or a role. And again, right, sometimes it's how you say things, not exactly what's being said, right? We talked about words having meaning. So if I say, for example, um, I want you to answer people in a friendly, professional manner, be firm and assertive, but not disrespectful, right? We're saying to the LLM, it's how you say it, which is sometimes more important than what is actually being said. Examples, right? So we were talking about context earlier. You could give the LLM some examples to help with the response, right? So if I say, hey, write a test, and if I give it an example of one of our tests, it'll use that example to help write the response, right? The example will heavily influence, or list of examples will heavily influence the the response. Constraints and guidelines. So these are the do's and the don'ts. So, for example, you could say to the LLM, I don't want you to give any sort of legal advice. I want you to end every legal statement with, warning, this is not real legal advice. Please consult an expert attorney for real advice on your situation, right? So these are kind of like guardrails for your LLM, what it can and cannot do. Here's another example from the Google prompt engineering paper. And you'll see that there are four main areas to consider when writing an effective prompt, right? So they claim persona, task, context, and format are very important. And we could see that in the example below, right? So you are a program manager in industry. Draft an executive summary email to persona based on details about relevant program docs. Limit to bullet points, right? So we can see how some of these key parts of a prompt are made up in this example, right? We are combining some of the things we learned into this really good prompt that utilizes these four different areas. We also talked a little bit about examples, right? So if you don't give an example, that's called a zero shot prompt, right? So let's say I want you to pretend to be a customer greeter, right? I didn't give it any examples. I just said, hey, go do it. One shot prompting, I want you to pretend to be a customer greeter. Um, and an example of something you would say to customers is hello and welcome to the store, right? So I gave it one example. Few shot prompting. So this is giving multiple examples to the LLM, right? We're giving a few examples. So I want you to pretend to be a customer greeter. Some examples you could say to customers are hello and welcome to the store. Hi, how's your day going? Thanks for coming to visit. So few shot prompting is especially important because the higher quality examples you give it, the better performance you can expect, especially when sampling different parts of a data set. So a mixture of very high quality and a variety of these high quality examples can really improve your performance and your mileage when talking to LLMs. And you can also see I've got some research paper linked down there. According to the paper from researchers at Brown, they studied GPT-3 and it can perform a lot better by conditioning on a few examples provided in the input prompt, eliminating the need for task-specific fine-tuning. So we don't need to know what fine-tuning is exactly, like under the hood, how it works, but just know that if you just give it a few examples, your inputs your performance and mileage from using an LLM will be so much better. We're also going to get into a little bit of the different types of prompts. So I'm not going to read all of these. We're going to get into them. But just know there are a lot of different techniques we can use when talking to LLMs and writing these prompts. System, role, and contextual prompting. right? So this technique is, for example, from this point on, we're going to ask it to be a pirate. Answer every question henceforth in a pirate voice. Don't forget to ask people to walk the plank, pretend we're on a ship and you're the captain steering us to find some booty. So if I ask, after that system prompt, I say, Captain, where are we headed? The response would be, here's an example, Arg, fine matey. Um, we be heading west straight into the Crimson Reaches. And you can see the rest. So a system rule and contextual prompt, we're giving the prompt we're in the prompt, we're saying how we want him to talk, some context of where we're at right now, right? We're on a ship. The role, I want it to be a captain steering us to find some treasure. So this is a type of a prompting technique. Step back prompting. So I'm just going to go into the example, right? So let's say first I say, what is the best stack for developing a full stack web application? Pick the best one, please, and tell me in a short sentence. So the AI comes back. The best stack for developing a full stack web application is Next.js, React, Node, and Postgres. And you could see a little bit why it said that. Given your answer, what is the best way I can implement an auth for that stack? So we took a step back and said, hey, what's the best way to do something? And then after it gave us a response, okay, now go do it, right? So what is the best way to do something? And given your answer, now that it came back to me with how I should do something, then how could I go ahead and do something with that? So I took a step back in order to take a step forward. Another one you guys will see, and you've seen this a lot in reasoning models, is chain of thought prompting, right? So if I ask it, to solve this really hard math problem, usually if I'm not using a reasoning model, it'll just spit out an answer. But if you want to see the breakdown and its thought process, you can usually ask the model to use this chain of thought, or hey, give me your step by step, show me your thinking of how you got to that answer, so you can verify step by step at each calculation or each kind of point it makes that it's correct. So you just want to see its chain of thought. So just a quick aside on pricing. The way these models usually work is if you are, for example, working with an API, and they're billed by a million input and output tokens. For example, if I put in a million input prompt tokens in your prompt, and you get back a million token output response, you'll be billed $2.50 and $10 respectively for, let's say, a specific model. And these prices can vary, but this does not apply when you use the models directly on the model provider website. Usually they've got like rate limiting, or they make you pay anyways. But as we continue to learn about prompts, we can see how we can save money, and also save time, and also more efficiently use these models, so that we're not being billed like crazy amounts when using, like, for example, their APIs. Self consistency. So a common pitfall with LLMs is thinking that the bigger the model gets, the better it gets. So unfortunately, bigger is not always better, and we need techniques to teach the model how to think. So as we saw with chain of thought, right, models can break down problems step by step. One issue, however, is that chain of thought uses this thing called a greedy decoding strategy, which limits its effectiveness. Greedy means that um, at each step, it's going to choose the word token with the highest probability. So this is great if you need some deterministic result, but sometimes we need an LLM to be probabilistic, right? We want it to consider other approaches. So self consistency combines things like sampling and majority voting to generate diverse reasoning paths and select the most consistent answer, right? So self consistency is kind of like a way for it to say, okay, there are a couple ways of going about a problem. I'm going to think of, I'm going to go through a couple iterations and see if I can find, explore like different paths. And at the end, I'm going to see what the most consistent answer was after I've gone through those paths. So here's a classic example using email. So imagine we're trying to classify an email. Um, I, I prompt the email 3 separate times to determine if the email is important. And the first time it thought it was important, the second time it thought it wasn't important, and then the third time it thought it was important. Each of these branches were like different approaches it was thinking, and came up with to maybe come to the conclusion that it was or wasn't important. But after 3 attempts, we take the quorum of the most consistent answer, and we saw that we've got two importance and one not important, so that we would then conclude using this technique that the email is important, right? Because 2/1. So now that we're familiar with chain of thought and self consistency prompting, let's review this other thing called trees of thought. It generalizes the concept of chain of thought prompting because it allows LLMs to explore multiple different reasoning paths simultaneously rather than following a linear chain of thought, right? So at each part of the the chain, right, where it thinks of different paths, it's going to choose at each step the most probable path, right? So at each path, you're not going down all the way, you're making a decision, right? That, hey, okay, we think that maybe this is the right answer. We're going to keep going. We think that at the next step, this is probably the right answer, and so on and so forth until it gets to the bottom output, which is your final answer, right? So we talked about these three different methods. What makes them different between the three, right? So the main points here is that chain of thought is usually used for like simple tasks, right? Self consistency is usually for medium kind of tasks, or if you just need a second or third opinion. But trees of thought is really for exploring very complex problems, and these can be very expensive in terms of compute, money, time, but you're really thinking through each step. So just three different ways to explore problems and get an answer. Another technique that we see is this thing called react, reason, and act. So if we think about this prompt method, for example, I want to find out how many kids do the band members of Metallica have. The answer would involve needing the LLM to make a search for each band member using an API I gave it, right? So the way I like to think about this method specifically is we want to equip the the in our prompts the LLM with tools so it can reason about its answer, right? So um, you first look up how many members the band has, find each of their names, and then for each of those members you're going to do a tool call, and you're going to look up how many kids that member has, and then at the end you'll get your final result. So by now you're probably tired of learning all of these different prompt techniques. Thankfully, this last technique is called auto prompting or automatic prompt engineering. um, so usually this is just involving the LLM to help write the prompt for you. So all you have to do is ask the LLM to give you some feedback on your prompt, and you can use, some of the tools and techniques you have learned to help plan, write, evaluate, filter, transform, and give feedback on your prompt, right? Your initial prompt. This is also called like human in the loop, right? Where usually the LLM will help, take control of the steering wheel, but you want to have a human, you, be in the loop so that you can give feedback to the AI or the chatbot you're working with so that you can refine your prompt or refine your answers. You can also ask the AI to help evaluate the prompt for you. So you can have basically the AI do everything for you. This is called fully autonomous. a little bit about prompt engineering for code. Some of the things you can have in your prompts and ask AI to do for you is you can ask it to write code, explain code, translate code, debug, review code, and you can also have it work with different modalities such as text, video, audio. You can have it work in your IDE. So there's different ways of um, having an LLM, of working with an LLM, and different ways of interacting with it. So let's go through some different personas and use cases, right? So business leader would probably use, like AI and these prompts techniques to make decisions faster, right? Like analyzing a market trend or creating ideas for growth. PM could probably use these techniques to think of new features, investigate new features, prioritize features, uh, coordinate features. So software engineers, we just talked about writing code, and you can see the rest there. Designers, right? Quickly iterating, mocking up designs, getting feedback. Sales, right? Useful for crafting different emails, generating leads, and preparing for client conversations. Coming up near the end here, you'll see a lot of times the AI can sometimes hallucinate. You'll be like, wow, where did it get this answer? So, in an effort to avoid hallucinations, we saw some of our sampling techniques earlier, but in terms of prompts, right, we want to be clear and specific. We want to break down our complex prompts, into like more of a smaller, more manageable chunks of work. We want to constrain the LLM so it doesn't get too creative. We want to prompt for verification, right? We want to structure the prompt so that we can encourage it to verify where it's getting its information from. Also, sampling, like we talked about. I've got another bonus in here for you guys. So, we're going to talk a little bit about RAG and how it pertains to prompts. So, RAG standing for Retrieval Augmented Generation. Just think of giving the LLM think of like a document in order for it to, reference when you ask questions. So in your prompts, you can ask the LLM to retrieve or recall from that document, right? So if I say, hey, like here's a document on, I don't know, the US Constitution, I could ask about what the First Amendment is and ask it to cross reference it with the US Constitution, right? So there are ways that you can reference documents and prompt the AI to grab information from a document. Another bonus, so kind of a thing that's going around right now is this exploit called prompt injection. Just know that people are looking to hijack these prompts, specifically kind of more so system prompts, right? We talked about system prompts being kind of that overarching meta prompt that kind of influences every other prompt that you ask it, right? So prompt injection means that people are trying to hijack these prompts just because of how valuable they are and in terms of generating output. So just something to keep in mind as you're working. Wrapping up here, some of the best practices. We want to be clear, concise, and direct. We want to show and don't tell. We want to use examples. We want to be explicit. We want to evaluate, iterate, and incorporate feedback. We want to use our different thinking techniques that we learned about. There is a thing as too much context. I'm kind of coining as TMI, too much information. So we want to be purposeful about the different examples we give it. We don't want to overload it with irrelevant information. We want to use guardrails, right? We want to use constraints so it doesn't go too crazy. And we want to know when it's time to be creative versus when it's time for the answer to be certain. Finally, some references of sources that I was using throughout this presentation. So thank you very much.